All right, today we're going to talk about factoring. I know we covered a little bit of this earlier in the year. We're going to go through it again. This is something you'll need as we move forward and any higher level math classes. This is one of those skills that you're going to just have to learn to be good at. All right, so this is kind of a flow chart. This is published in Schoology for you, so you can refer back to it as you're going through your work. But so we're looking at this point, we're talking about 2 terms and 3 terms. The 4 terms, the grouping, that's something we will look at next week going forward. All right, so we're going to start with 3 terms. This is something we did when we factored quadratics. So 3 terms are typically our quadratics that we're going to factor. So mostly this is guess and check. So the key here is these pieces. So if I have a plus at the back, that means the signs are going to be the same, and they will be whatever the middle term is. So if you look at number 1, my signs, when I factor this, are going to both be positive. All right, if I have a negative, this means my signs, one of them is going to be positive and one of them is going to be negative, because remember, I'm multiplying these back terms, these end terms. So in order to, if I multiply a positive and negative, I'll get a negative. If I multiply a positive and positive, I'll get positive. If this 25 in the middle was negative, both these signs would have to be negative. So if I multiply them together, I get a positive. All right, but the first thing I need to do is at the top. So always look for a greatest common factor first. Is there something I can take out of all of these terms that will make this simpler to work with? And if I'm looking at number 1, if you notice, 5 goes into all of those numbers. So I can pull that 5 out. And that's my new term. Now this isn't the factored form yet. All right, so I've got an n plus and an n plus. All right, so now I'm looking at factors of 4 that add to 5. So my factors of 4 are 1 and 4 and 2 and 2. Well, I only have one option here. 2 and 2 add to 2, 1 and 4 add to 5. So those are the numbers that are going to go to fill out those parentheses. All right, so the next one, I have an r squared. There's no number out front, so I can just separate my r's like that. So I'm looking for factors of negative 9. That add to negative 8. So my factors of negative 9, I've got 1 and 9 and 3 and 3. So a combination of one's positive, one's negative. All right, so 3 and 3 obviously isn't going to get me there. But 9 and 1 has potential. So I need to get to negative 8. So we have to decide which one's going to be positive, which one's going to be negative. So in this case, we know that I'm going to have a negative 9 plus 1 to get me a negative 8, which means I'm going to end up with a minus 9 and a plus 1. So now we can pop these into our boxes, multiply them like we did before, and check that our answers work. I'm not going to do that so I don't run out of time on my video, but I encourage you to do that with your homework. If you're not sure if you put the numbers in the right place, put them in the boxes and see if they multiply out so you end up back with your original starting term. All right, so what happens when the number in front is not 1 and I can't take anything out? So like number 3 in this case, there's nothing that's going to factor out of there, and I've got this 5 out front and I've got a 32 at the back, and I need to get to 12. So I'm going to take factors of 5 and factors of 32. We're going to multiply those together, and we are going to add those factors, multiplied factors, to get 12. So my factors of 5, I've only got 1 and 5, so that's not so bad. 32, I've got 1 and 32, 2, 16, 4, and 8. All right, so now I'm going to take combinations of these. Okay, so my options are So 1 times 1 is 1, and 32 times 5, that's obviously not going to get me to 12 because I've got some really big numbers. If I flip it around, I've got 32, so 32 times 1, and then I've got 5 times 1, so looking at it that way. That's still not going to get me to 12, so I can scratch that one off the list. Next up, I've got 2 and 16, so I've got 2 and 16 times 5, which is going to get bigger and bigger. That one's obviously not going to work. Other way around, I've got 16 and 10. It's still not going to get me to 12, but we're closer. All right, so I'm looking at 4 and 8. So I've got 4 and 8 times 5, which is 40. Well, that one's not it. And I've got 8 times 1 and 4 times 5, which is 20. So remember, now my answer at the back is negative. So one of these has to be positive and one has to be negative. One of these also has to be 5x and one has to be regular x, just 1x. All right, so we need our 20 to be positive and our 8 to be negative, right? Because we're looking for a positive 12. So which means to get this 20, I had a 4 times 5. So my 4 is going to have to go there. Those when multiplied together have to be positive, so I'm going to put my plus there. And my minus 8 is going to go there. So if I put this into the boxes, and multiply this out, so I've got 5x squared, I've got a negative 8x, I've got 20x, and I've got a negative 32. So when I combine this, I get 5x squared, 20x, and a minus 8x gives me a plus 12x and a minus 32. So this one works out. We put everything in the right order. All right, I'm going to skip number 4. All right, difference of squares. So this F means first, and the L means last. All right, first thing again, we need to look for a common factor, see if there's something we can pull out to make this easier. And in this case, there is not. But I need to rewrite this 25n squared as something squared. So it needs to be something in parentheses squared. Well, so I know I've got an n. 25 is 5 squared. So I've got that. So this is my first term, or my first term is 5n. My last term is just simply 1. So I've got a 1. This is minus 1 squared. All right, so now I'm going to plug it into this formula. So I've got 5n plus 1 times 5n minus 1. And that is my factored form for the difference of squares. So same thing for this one. My first term is v. My last term is 3. So I end up with v plus 3 and v minus 3. Now, some of you might be able to just look at this and know what it is. We did this very similarly last week with conjugates. That's all this is we're multiplying by these are conjugates of each other, so it makes those middle terms fall out to give us the original equation that we started with. All right, so difference of cubes and sum of cubes. I don't know what the SOAP stands for, so we're going to skip that. All right, so we're doing this similar thing. So we're going to make all of these look like something cubed minus something cubed, or something cubed plus something cubed, and then we're going to just plug it into the formula. So this first one, this is our sum of cubes, because we're adding them together. So we need to rewrite this 24x cubed as something to the third. And I'm looking at this, and I've got a 3 at the back, and there's nothing to the third power that's going to give me 3. So I'm thinking I probably need to factor something out of there. Well, lo and behold, 3 comes out of both of those. So I'm left with 8x cubed plus 1. So this 3 is still going to stay on the outside. 8 is just simply 2 cubed. So I've got 2x cubed plus 1 cubed. So my first term, I don't know what all this beeping is going on here. All right, so my first term is 2x. My last term is 1. So we still have a 3 out front. We're going to take first, so 2x plus 1 times 2x squared. So we've got 4x squared minus, multiply them together, 2x plus 1. And that is the sum of cubes. All right, so difference of cubes, same process. We've got a 5 cubed minus 64 is 4a cubed. All right, my first term, we're going to keep it in the same order that it is in the equation because otherwise that negative will throw things off. All right, so we're looking at difference. This is our difference of cubes formula. Okay, so we're going to take our first, so 5 minus our last, 4a, times our first squared, so 25, plus our first times our last, so 20a, plus our last squared, so we've got 16a squared. And that is the difference of cubes. And that's as simple as that is going to get. All right, so what happens when that term in front is not 1 and there's a lot of factors? So we could guess and check. So this would be factors of 9 and factors of 4. We need to multiply those together and make sure that they add to 9. All right, well, the factors of 9, I've got 1 and 9 and 3 and 3. And for 4, I've got 1 and 4 and 2 and 2. And that's not too bad. I could do it. And there's lots of shortcuts to do this. And the one I'm going to show you today is called the slide divide bottoms up. All right, so what that means is I'm going to slide my 9. So I'm going to take my 9 and I'm going to multiply it by my negative 4. So this new equation is going to give me my x squared plus 9x, and now 9 times 4, so minus a 36. All right, that's my new equation. Now I don't have a number in front of the x, so I can factor this. So I've got x, I've got a negative at the back. So I'm going to have a plus and a minus. So now I'm just looking at factors of 36. So I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9. And those need to add or subtract to get me to 9. Well, I'm looking, that one's obviously not it, that one's not it. So I'm looking at 3 and 12. My 9 is positive, so my bigger value is going to go there. My smaller value is going to go there. But now if I pop this into my boxes, it's not going to give me that equation that I started with. So that's where this divide comes from. Okay, so now I'm going to divide the constant by this number that I multiplied with. So I'm going to divide by my 9. So divide by our a term. Remember when we talked about our quadratic, so we had ax squared plus bx plus c. So we're going to divide by our a term. And now we're going to simplify these. So 3 goes into both 12 and 9, so I've got 4 and 3. 3 goes into both 3 and 9, so I've got 1 over 3. All right, so then this is where the bottoms up comes from. Now I'm going to take my 3, my number on the bottom, I'm going to pop it in front of my x. So I actually have 3x plus 4 and 3x minus 1. All right, and that is slide divide bottoms up. All right, I could put this into boxes, check to make sure it works, and it will. All right, so we're going to do the same thing with this last one. So we are going to slide our 6 over. So we're left with n squared plus 31n plus 18 times 6 is 108. All right, so now I need factors of 108 that are going to add to 31. So factors of 108 are obviously 1 and 108, 2 and 54, 3 and 36, and 4 and 27. All right, I could probably go on, but I'm going to stop there. So if I'm looking at these, I know this one obviously doesn't work. 2 and 54, these are both plus, so we're not dealing with any minuses. So 54 plus 2 is 56, 36 and 3 is 39. I need 31. Lo and behold, there's my 4 and my 27. All right, now I'm going to divide by my original a term, which was 6. And I'm going to simplify. So 2 goes into both of those. I've got a 2 and a 3. 3 goes into both of those. I've got a 9 and a 2. Now my bottom's up, so I'm going to take my number on the bottom, slide it in front of my